maybe our version of it is like people should be proud that they're using more clean, cheap energy,
Mm.
saving money on their energy bills, but also proud of the thing that's in their home. So you should only put things in your home that you love, objects that you find valuable and interesting. And so, yeah, I kind of hope that people will kind of show these off and tell people about it. And that'll be a large part of how we we get more batteries out there and more renewables on the grid.
For decades, the clean energy transition has been promising to reduce bills, cut emissions, and give households more control over their energy. And it has, mostly for households with a roof or a driveway and a landlord who happens to be themselves. For everyone else, and that's roughly half of the population of Europe living in flats, like me, and rented homes, almost none of this has landed. Smart tariffs, the next generation, assume you own an EV. Rooftop solar assumes you own a roof. Home batteries assume a professional installer's and a wall you're allowed to drill into. Ashley Grealish has spent his career thinking about exactly this kind of gap. At Bboxx, he helped bring solar energy to 500,000 homes in rural East Africa using pay-as-you-go models and IoT systems built around people with no upfront capital. At ev.energy, he built smart charging infrastructure and pushed against the assumption that it should only work for premium vehicles. Now, with Windfall Energy, he's asking a simpler and more uncomfortable question. If you live in a flat in London, or Paris, or Rome, or wherever, why can't you have a home battery that just works? The answer is Windfall. Windfall is building towards a 2.5 kilowatt hour battery that plugs into a standard socket, arrives overnight, and optimizes itself around the grid. No installation, no app overload, no lifestyle change required. Small enough to sit in a corner and designed to be really pretty and be lived with for a decade or more. So this episode is about what it actually takes to build a clean energy product for people who have consistently been designed around rather than designed for, and what that reveals about the architecture of the transition itself. Ashley, welcome to the show.
Thank you. Thank you. Great to be here. And that was a great intro. So thank you for that.
So, Ashley, you have really started with the very different context, right? With the Bboxx, while I still at Imperial, you got involved some student initiatives. You've been bringing off-grid energy to rural communities in East Africa. And you studied engineering, right? And most engineering students don't really end up there, right?
Yeah.
What makes you laugh? So what drew you to that problem so early?
So I studied electronic engineering at Imperial, and when I was in school, the first iPhone had just been released, and I got really interested in this technology and decided that I wanted to design the future of mobile phones. An internship at a place called ARM. ARM make the chips inside of phones. And I was there doing a kind of summer internship there when just before that, a friend had come to me and said, actually, we've got this like technical problem with some code that we're trying to run on the device. We're building this thing. It was a flatmate of mine. And she was doing this thing to look at homes that don't have grid access across East Africa, put solar panels in the village and batteries, and charged off those solar panels to bring to and from homes to give them power. And they had made their own kind of test device, and they were struggling to get the code working. So the first thing was just like this, oh yeah, sure, I'll help you out, you're a friend. Whilst I was working at ARM doing the thing that I thought I wanted to do. But I got more and more involved in this project and was looking at clean energy tech. The price of solar panels was falling rapidly the price of batteries. This is quite a long time ago, but even then, the price of batteries was falling rapidly. And we were doing, as a student organization, I got more and more involved in this thing that would build central solar panels in the middle of a village on a building, and small batteries that would get charged in the center, then taken to a house, rented one at a time, one charge at a time to power lights. So I got really interested in this, became kind of a bit obsessed with this idea, but thought that we could do one step better, which was, what if we don't put all the solar panels together in the center? Instead, put a solar panel on every house
Mm.
and sell them on a model that is pay as you go. So pay monthly for your access to energy rather than all in one go. It felt like there was something really interesting there because
Mm-mm.
of that inflection point with solar panel prices, things like that. So talking with this friend, ended up going to Rwanda for the first time to help them with their project. And then the next year decided that my master's thesis should be based around this. Can we make a pay-as-you-go solar product that works in the area of Rwanda where we were operating? So we made 100 of these small scale, small home solar panels, batteries with a kind of little, you text your payment, you get the code back, you type it into the box, and it would work for a week or a month, depending on how much you paid. And so this just became, I just love the kind of design, the like seeing the real impact, seeing what this could do to
Mm-mm.
people that were living without grid access using
Mm-mm.
kerosene lamps typically. We saw the impact that could have, and that became far more interesting to me than designing like the next iteration of a mobile phone.
Yeah, I totally get it. And that's not very often that I get to meet people who have experience both in developing countries where the need is so for clean energy and for decentralized solution is so urgent, and also at European level, right? At working in European countries. And a few years ago, I worked in Burkina Faso and Madagascar
Mm.
on demand side flexibility in mini grid access and nano grid access.
Okay.
And that was also so, kind of enlightening to see how much these solutions could have like such an impact so quickly, right? But at the
Yeah.
same time, it really requires a lot of monitoring, because it's not like, I mean, in Europe, we are kind of used to our big fat energy systems
Yeah.
that are very much like, steaming ships or something like that. They're like kind of immovable. Well, sometimes there is an iceberg, like one is
Yeah.
coming, but usually they are very, very steady and so on. And so, the approach there is completely different. It's something that really needs to kind of start from scratch. So we also need, as someone coming from the outside, we need to learn from the local experience to see how that will fit and really adapt to the local
Yeah.
context. So there were probably things at my side. There were so many things I had to learn and unlearn, but I'm sure you also had some. So can you tell us a little bit more about your experience in Kenya and Rwanda for this project?
Yeah. I mean, there were we learned so many so many things, of course.
Yeah.
I think kind of touching on what you were first saying there. One thing we learned, so at Equinox as a student, we built 100 of these pay-as-you-go solar products, and then that morphed into I joined a startup called Bboxx to build these kind of commercially. And I think one interesting thing that came out of that was pushing to do more than lights and phone charging. Can we can we fulfill the demand to have radios, TVs, this sort of thing? And the obvious solution would be to just kind of go and buy a cheap, normal
Mm.
TV, try and sell that alongside a solar panel and a battery. But if you do that, because the TV is kind of AC powered and optimized for low cost rather than high efficiency, it means you need a really big battery and solar panel to power it. So kind of touching on your thing about rethinking systems, we tried to rethink the whole system here and
Yeah.
be like, what if we optimize the TV to be
Yeah.
really low power? And actually we took a lot of technology that was used from like caravans and camper vans, 12-volt
yeah.
TVs,
Yeah.
really low power, designed for low power. If you
Yeah,
do that, you can really bring down the size of the solar panel and the
exactly.
battery you need and bring down ultimately the overall cost of the system. So
Hmm.
one thing we learned there is like think through the entire system of what we're building, not just try and kind of replicate what exists in other markets. So grid is the obvious example, but then even down to the appliances, let's not just use appliances that exist. Let's think of a new kind of energy system
Yeah.
here that is optimized to be low power. So I know this is primarily an audio thing, but for anyone behind me, you can see this is the small battery at Bboxx with the small solar panel, about the size of a laptop, but a bit thicker.
Hmm.
Like this can power TVs, radios, mobile phones,
Hmm.
lots of lights, like not just really low energy things. So you can do a lot more if you think through the systems.
Yeah.
And yeah, I mean, Bboxx as a company, we designed the products, we manufactured the products, but we also had the distribution networks in all of the countries that we worked in. 14 when I left, if I remember correctly, 14 different markets.
Wow.
Um, and again, like thinking through that entire system, being able to build a kind of software platform that powers all of that, that was kind of some of the big the big advantage we had to do and deliver this cheaply was by thinking through that entire end-to-end experience. So circularity being a big part of it. These batteries, lithium batteries, were quite expensive then.
Hmm.
And so we use lead acid batteries in the first generation of this product. And lead acid batteries can be recycled quite well. And
Hmm.
so by having a kind of circular supply chain, we could take back those lead acid batteries, recycle them, capture most of the value of, or most of the cost that we spent on buying that battery back
Yeah.
at the end of life, and then kind of redeploy it lots of times. So loads of really interesting kind of like circularity
Yeah.
lessons that we struggle with in in markets like the UK, but was just
Mm.
inherent to making the model work low cost for
Th-
Bboxx.
that's so interesting. I mean, the fact that you think about the circularity, you really embed the product within a bigger system, right? And I think it's pretty rare that people working in this kind of development and IT are they embracing so much this dimension, right? The question of the repurposing of the solar panels, the question of the repurposing or what you do with the battery afterwards always comes back, and it seems to be like, like this never ending conversation. The problem is that these batteries end up in nature and so on, and so what do we do? So, the fact that you had really thought it through and thought about really that makes you like position you somewhere very particular place in the supply chain itself, right? Because you're both your supplier and and the developer, and so that makes it really super interesting. So you really have something around traceability, right? It's not only like the batteries you were interested
Yeah.
in traceability. You also have an experience with gems and
Yeah,
diamonds, right?
diamond mining.
Yeah. Wow.
I can explain. The jump is not obvious, but yeah, I got really interested towards the kind of end of my time at Bboxx, spending a lot of time in Rwanda. I remember it was a particular trip. I was sat with one of the team from Rwanda, and he was telling me about his family and what his family do for a living. And he was talking about small scale mining. And in electronics, there are these things called tantalum capacitors, certain types of certain type of device. And basically, his family were kind of mining a very small scale the metals and minerals that go into that. And then we were looking at the future of the clean energy transition with kind of this was when Teslas very early were just
Mm.
taking off, right? Electric vehicles were going to be a big thing. And there's a lot of metals and minerals that go into batteries, a lot of which for the Tesla NMC batteries particularly, were coming from that border between Rwanda and Congo. So we're
Mm.
spending a lot of time and a lot of focus of our work. We also had operations in DRC as well.
Mhm.
And so I got really interested in like, how is this clean energy transition going to change the kind of the metals and minerals that we need to mine, and how do we do that in a fair and traceable way? I started to get interested in that, and then I went for a coffee with a friend about a completely unrelated topic, and he told me that he knew someone that was looking for help to start a kind of traceability mining business. It was a corporate startup, a corporate kind of spin out, and it was called Gemfair. And the idea was to sit as part of Anglo American and De Beers group, start by mining diamonds, and then move on to mining gold, cobalt, all of the other things that go into electronics. The reason we started with diamonds specifically is because most of the other things I mentioned get smelted at some point in the process, mixed together, melted down. That's quite a hard traceability challenge. But diamonds are kind of mined in a similar way, but they don't get smelted. They get kind of cut up, and you can prove out traceability much, much more easily to start with. So I ended up, working on a thing called Gemfair, which is super exciting, working on small scale mine sites in northeastern Sierra Leone. And we were going to small scale mine sites, kind of doing training and things around environmental processes and all of this sort of thing. And then kind of auditing that those things were actually happening. And if they were, if that mine site was fair and ethical and safe and all of those things, then we would buy those diamonds from the mine site and then skip all of the normal middle layers that happen in the diamond supply chain. So we can capture far more of the kind of value for the miner, give them a much better price, and then sell it direct to on the kind of larger diamond miner without all of those layers in the middle. So that was super exciting. I think sounded really easy at the start, turned out to be quite hard, but Gemfair still exists, doing great things in the diamond space. I'm not sure yet, but I know when I left, we hadn't quite made it out to the other things I was more interested in, the gold, the cobalt, the other metals and minerals. But I know there is lots of great stuff happening in that space. Anyway, some people from Bboxx are actually involved in that now in a separate startup.
That's great. And we're getting closer to what Windfall is, but between Windfall and Gemfair, you also worked on making a non-premium electric vehicle something really like achievable, affordable, like something people could really want. So, I mean, where does this instinct really to work on the corners of the energy transition come from? That's really fascinating. You know, when you were talking, I was thinking, I mean, who is he? Who's this guy? He's a serial entrepreneur. Is he a bit like Indiana Jones looking for a treasure in the middle of the jungle or something? But he has a British accent, so he might be James Bond. So I don't know. Ashley, tell me. Where does this come from?
Honestly, I don't really know. I look back on my career and think like, there was never really a plan. Like a lot of these jumps to different areas have been, like I mentioned with one of them, going for a coffee with a friend. Like I think it's probably, my partner always says I ask a lot of questions. I'm just really curious to learn lots of things, and so I think it's that, just like really wanting to like sat in a car chatting with this guy about mining. It just like opened my eyes to this whole world that I didn't know about, and then got perhaps a little bit obsessive about it. But yeah, like ev.energy is the one you mentioned. The next thing, the EV charging one. Similarly, again, I don't think it was a planned, intentional move into the EV space. Obviously, I was interested in electric cars. They were starting to become a thing. Really only Tesla and Nissan Leaf at the time, but started to see them, started to drive some occasionally. I thought it felt like that was going to be an interesting area. And then happened to chat to another friend who happened to be working in that area and joined early on in that journey. But yeah, to tell you what that was, it was thinking that we have two things happening. EVs
Mm-hmm.
growing in
Yeah.
numbers on the road, and an energy transition on the grid. So more and more renewables
Mm-hmm.
happening. Cars don't have to charge exactly when you plug them in, right? You have some flexibility. You can wait to charge later in the night or even like in a few days' time, because you don't normally need to fully charge your car
Mm-hmm.
every night, unless you're driving an extreme amount, which most people aren't. And renewables are kind of intermittent. And so
Mm.
what if we can just make those things work well together, change when and how a car charges to suit when renewables are most abundant? So I joined a company called ev.energy. I can't remember exactly. It was less than 10 people in the company then, to bring some of the experience from Bboxx
Mm-hmm.
to them. And the idea was, let's build a platform that connects all of the cars, all of the chargers together into one platform. And on the other side of that, connect it to the energy system. So having connected, as you said, nearly 1 million batteries across Rwanda, Kenya, Uganda, we thought we can definitely connect
Yeah. Looks
cars and
easy.
chargers across the UK. Again, always turns out not to be quite as simple as we thought. But yeah, that platform grew and grew, and now ev.energy is powering a big chunk of the kind of charging programs across the United States. So if you have an EV in, say, New York, and you
Mm-hmm.
want to get cheaper charging for your car, you connect it with their smart charge program. Then ev.energy optimizes when that car charges to suit the lower cost time. So we connected, hundreds of thousands of cars into programs there.
So cool. I mean, so practical, and it really fits into the vehicle to grid conversation that we had a couple of years ago, I think now
Yeah,
on the podcast. So, but I mean, you started working with battery then, and you brought them to the home. So behind you, we see one of the
yeah,
windfall batteries. Can you show it with your hands, please?
I'll try.
Yeah.
That's there.
Yeah, it's here. So it is designed to look good. I haven't seen it like in person, but it
Yeah,
really, like from what I've seen also on your website and so on, it looks really nice. It's 2.5 kilowatt hour. It's plug-in. You've described wanting it to feel like ordering a printer and
yeah,
really deliver it overnight. You plug it in, it works. So tell me a little bit more about where the idea come from. Again, well, now we have an
yeah.
idea where the idea come from, but really,
Well, yeah,
what kind of constraints did you want to play around to make it kind of mainstream?
of course. So I guess the backstory is ev.energy we just talked about. I was there for 5 years, decided I
Mm,
wanted to do something new. I hadn't decided what yet. Had some ideas, went on a long road trip around Europe, thought about those ideas, decided they weren't great ideas. So put those on pause. But again, going out, speaking with people, I ended up chatting with a guy called Rob, who is now my co-founder. And I was presenting at an event about the work I had done at ev.energy, and more generally talking about how connected devices, connected devices can transform the energy system. And he kind of challenged me afterwards, and there was a small group of people around how this is very true. We can connect cars, we can connect heat pumps, batteries, these sorts of things. But actually, in this small group that we were discussing in, it wouldn't work for any of us because we all lived in and around London,
mm,
either in flats or rental homes or smaller terraced homes. And this
mm-hmm,
group was only a small group. But then I started to think about my mum. She has a small terraced home outside of London with not very much roof space at all. I've tried to convince her to get solar before, and it just doesn't work.
mm-hmm.
My sister, she rents a house. I just thought more and more like there is a big missing kind of or ignored set of the
Yeah,
population that can't
yeah.
actually do anything. And my
Mm-hmm,
intuition was that actually that that set of the population is probably quite determined to do something about climate change. Um, don't have any hard facts on that, but it felt kind of felt kind of right. And so Rob and I decided that we should do something about that. Did some more research, found out, as you said, that it's over 50% of homes in
Mm-hmm.
the UK and in Europe. And we didn't have a clear idea of what we wanted to do yet. We didn't know what the solution was. So we did a few interesting experiments with energy flexibility. Can we use more energy when it's abundant, when renewable energy is abundant?
Mm-hmm.
Tried to control things like dehumidifiers, heated closed areas, loads of other things, electric wheelchairs and mobility chairs, things like that.
Mm-hmm.
And it was really interesting. We learned a lot from that, but really we found that alone those things don't have a big impact on bills. And so to
Mm-hmm.
have a big impact on bills, you need to affect everything in the home. And some people in our experiment were adding batteries into the experiment and seeing, can I store up power in batteries when it's clean and cheap and use
Mm-hmm.
it at a later time?
Yeah.
So that was the kind of crux of the idea. And those
Yeah.
batteries in that trial, people were using like, I call them camping batteries. So these big,
Mm-hmm.
designed to be moved around, take camping, charge up your stuff, these big rugged things. And we thought, like, this is fundamentally here a good idea, but
Mm-hmm.
it's quite hard to make it work. And we need to make it much easier. We need to make it something people want. We need to make it work in all types of homes. And
Mm-hmm.
so myself, Rob, and then our designer Ben spent a long time thinking about what are all the challenges that will stop people getting batteries in their home. So we ordered a bunch to my house. We drove to Germany to pick up some from the balcony solar kind of side, brought them
Mm-hmm.
back. My flat is a bit cleaner now, but at one point it was full of test batteries. And there were so many issues we came across. So one got delivered on a massive lorry truck thing on a
Oops.
crate, put at the bottom of my flat. It was 45 kilos for a 2.5 kilowatt hour battery.
Wow.
And the delivery driver was like, I'm only paid to deliver it downstairs.
What
You've
do
got to
we
work
do
out how
now?
to get it upstairs. And
Okay.
I got it upstairs eventually, but I was sore the next day. I ached.
Yeah. Who needs to go to
Um,
the gym?
exactly. And then once they were in the flat, so many of them were really loud, lots of fans.
Uh-huh.
A lot of them had bright blue lights on them that made this room look a bit wild.
Yeah, like a
Um,
disco.
yeah, just flashing, all so bright, and all these things. And we just thought, like, these aren't designed to be. Well, they are. They're not designed to be in people's homes. They're well
Yeah.
designed to be in people's
Yeah.
homes. Like I'm really motivated by this idea, but I didn't want these things in my
Yeah.
home, and so
Yeah.
let's just design something that thinks through the end-to-end journey, makes it easy to deliver to your house, makes it
Mm-mm.
something that doesn't wake you up at 2 a.m. with a loud fan when it's charging, doesn't
Mm-hmm.
shine bright lights all over the place and distract people, and make it something desirable, make it something
Yeah.
that people want in their homes now, but also in 10 years' time, because the batteries are going to last a long time. It has to last for 10 years as well. So, yeah,
Mm.
we did a lot of work on that kind of design of the object itself, but the whole service around it.
Yeah, that's interesting because I mean, in a way, you started with the conversation with the iPhones, and one of the things
Mm,
that really made a difference with iPhones was the design, and iPods and iPhones
yeah,
compared to I remember the USB keys and USB where you could listen to music with the MP3 and stuff like
yeah,
that, and they look just ugly. And then came Apple with this kind of shiny new things,
yeah,
and suddenly it becomes something you want in your home, and it also becomes a status symbol, right? So
yeah,
should
yeah,
battery become a status symbol at one point?
yeah. Why not?
Why not?
I think
Because
people
yeah.
should be. I think a really interesting question. I think there's a thing that was reported in the UK a little while ago, maybe elsewhere too, called about like the spread of clean energy products and attributing it to the heat pump dad. So someone gets a heat pump and they get really into it, love looking at the data, these like real early adopters, and then they go and tell everyone about it. And then that's how kind of heat pumps have spread. But heat pumps have spread, I would say, fairly slowly because they're very techy, and looking at your friend's data on a screen probably isn't that interesting. But I haven't really thought about this before, but maybe our version of it is like people should be proud that they're using more clean, cheap energy, saving money on their energy bills, but also proud of the thing that's in their home. So you should only put things in your home that you love, objects that you find valuable and interesting. And so, yeah, I kind of hope that people will kind of show these off and tell people about it, and that'll be a large part of how we we get more batteries out there and more renewables on the grid. But yeah, I haven't really thought about that before.
Yeah, no, it's I mean, I think it's really cool that you pay so much attention to the look and to the aspect of this thing, right? Because I mean, if you can afford new appliances and so on, you want them to look good. So if that's the only thing that blocks you from getting a battery in your home, that would be quite a shame. So you kind of fix that gap, and that's pretty cool. You even did a limited edition version of the battery, right? I will let listeners check your website to see it, but I think it's a pretty cool thing. And just practically speaking, so 2.5 kilowatt hour, that would make my oven work, right, in the evening or something. Yeah.
So I'm going to use UK kind of stats here, but I imagine it's similar in Italy. But we've looked at the size for a few different lenses. So a flat typically might use something like 5 kilowatt hours of energy per day. And so by going at 2.5, we're not ever intending to kind of run the whole house for multiple days as like a backup battery. What it's designed to do is be able to charge in the really cheapest time when wind power, solar power are generating the most excess energy, the cheapest, sometimes even negatively priced energy. So if we can charge it up within 2 hours, we can really hit that like lowest value in the pricing. But more importantly, we can fully discharge that battery to power your home fully during the peak. So during that early evening peak, by having only 2.5 kilowatt hours of energy in there, we can discharge that into your oven, your fridge, your lights, whatever it is you're using, and fully discharge it at the peak of that pricing, which gives us this really optimized ROI or savings. And what's interesting is by designing it 2.5 kilowatt hours, that ROI works in every house. So if you have a small house, you hit the lowest point and the highest point and maximize the price delta and the arbitrage. If you have a bigger house, we still hit the same delta. It becomes a lower percentage savings of your overall bills, of course, but the ROI is kind of predictable in all homes, which again is something that I think is important to the design, like being able to confidently say like this is a sub 5-year payback without needing online calculators to look at all your data and process all of that and understand like, oh, for your house, actually, it's going to be longer. By being small, we can kind of predictably say how much it's going to save, which I think is really important. It also, like keeping it small, allows us to do the plug and play elements. It allows us to keep it under 30 kilos so we can deliver it easily. And so I think we're hitting that perfect sweet spot that makes the kind of, back to the Bboxx stuff, the whole system design work really well together as one kind of coherent product. So yeah, the 2.5 will power kind of half of your daily usage.
Yeah. No, that's very interesting also, because that's, that kind of fits also with this idea of sufficiency, that we need to, I mean, we shouldn't design things that are too big, right? We may not need them. And as our appliances get more energy efficient, maybe that's also something we should actually thrive for. And I presume that it also makes the appliance itself. Let's call it an appliance. This battery.
Yeah.
Maybe tomorrow it's going to be an appliance that you buy kind of anywhere, but that makes it also more affordable. And affordability is one of the things you're going to be working quite a lot. I mean, I know the UK has just passed a new bill to allow us balcony solar.
Yeah.
That's one of the reasons and why we connected in the first place, right? And you told me in the preliminary call that you were in conversation with the UK government about, the warm home discount to maybe to install this kind of small plug-in batteries. So there are many really opportunities to make it work for more and more people. I mean, that I really see like the continuity of the work that you performed in Africa with the really affordability as something central, because that's exactly like the solutions they cannot deliver if they only deliver for happy few, right? They have to deliver for the many.
Yeah, that's really interesting because I, again, haven't really made this connection in my head until this conversation. But at Bboxx, the batteries for East Africa, the business started by building batteries, building solar panels, and saying, you can buy this, it's $400, and then you get clean energy forever. Or not forever, but for a long time. And obviously, there are some people that bought those products, but a lot of people couldn't afford $400 upfront. And so that's where we went through that. How do we enable this pay-as-you-go payment plans to make this either no upfront cost or very small upfront cost, and then pay monthly beyond that? Where we are with Windfall Energy right now is at that similar first stage. So we just opened for pre-orders last week. People can buy a Windfall battery for £1,000 total, 100 as a deposit, 900 when we deliver later in the year. And there are definitely some people, because they've already done it. There are some people that want that and can afford that and are happy to pay the £1,000 and then get their money back over time. But if we want to make this way more accessible to everyone, we have to do something different. We have to make it zero or low upfront cost and still get instant kind of bill savings from the product. So I think thinking again about systems design, like one way to do this and solve two problems at one is to partner with energy suppliers. So one problem you can solve by doing that is kind of financing that battery on the bill, using the savings to pay off the cost, and making it kind of no upfront cost for the customer. And then they still get some savings on their bill. You mentioned Warm Homes Plan. If we can tap into funding available there, we maybe even can take this a step further by subsidizing a bunch of that cost and giving more of the savings to the customer more quickly, which makes it even better. But it doesn't depend on, like Bboxx, doesn't depend on subsidy. But there's a second thing that makes it a good path for us to partner with energy suppliers, and it's the one last bit of complexity that annoys me about this product. So if you buy this and you put it in your house, to save money on your energy bills, you need a certain tariff that has peak and off-peak pricing or variable pricing throughout the day. That's how it saves you money. It charges up when it's cheap, powers your home when it's expensive. Most people today don't have a tariff like that. And whilst they're widely available, it's a kind of complicated world. It's hard to know which of these tariffs is right for me. It's hard to model or kind of intuit which one is going to best suit your kind of lifestyle, your energy use. And then when you add the battery on, it gets even more complicated. So I would love to solve that last bit of complexity by partnering with an energy supplier and creating a new tariff with them that says, when you sign up for this tariff, we as an energy supplier will send you the battery. That allows us to optimize your home to be really low cost, using really low cost energy. And we will pass you a fixed amount of savings per month because you have this battery. in your home. So it becomes a much easier kind of decision here. No complex modeling of different tariffs in your head. You just know this tariff gets a fixed discount on my bill because I have the battery in my home. We're not quite there yet, but that's the vision. I think once we do that, we remove the two last kind of hurdles that I see: upfront cost and tariff complexity. So that's why we're really interested to do that.
Yeah, I mean, it makes the home almost a dispatchable asset. So that would be at scale. That would be really, really interesting. And I mean, I would also see how interesting it could be for, I don't know, appliance manufacturer and sellers and stuff like that also, because I mean, in a way, some could argue that the battery would come in competition to changing your dishwasher, washing machine, or something like that. But that would be complementary, right? There would be some complementary pathways. And now I'm thinking, for instance, in Italy, when you purchase your primary residence, you get some tax incentives to change your appliances, basically. Okay. Furniture and appliances. That's, this kind of tax credit for this kind of things. Yeah, it only benefits rich people, but that's still something to take into consideration. But, that could be relevant to have batteries inserted in the models as well. So it's probably one of the first time I have such a conversation about batteries, but I think it won't be the last. And I mean, there are so many kind of use I see to this technology. When are you planning to display it? Are you going to be in Brussels for the Sustainable Energy Week? Because I have a lot of listeners who will be there. So if you bring one of these, maybe in your luggage, like in the Eurostar.
So we did. We were, where were we? We were in Amsterdam 2 weeks ago at the Future of Utilities conference. That was the first time we brought this kind of real version of the product with us kind of outside of the office.
Does it have wheel? Does it have a name?
so there is a big flight case to carry around, and I'll reveal a little secret on the podcast. We took most of the batteries out of this one, so we can more easily carry it around, because 25 kilos is light for a battery. We can deliver it, but it's still quite a lot to carry around on the train. Like, so
spoiler alert, it's the weight of my child that wouldn't carry her all day.
Exactly. But to your question, Belgium, we don't have a plan to come do that, but maybe we'll chat after this podcast to see if we should come to that. We've just been through a kind of a run of launch party events starting in the Netherlands, as I said, but then last week was full of back-to-back events around London where we were taking this. And then I think Rob and I are taking a short break from events for now. And then hopefully, maybe we'll come to the one you mentioned, maybe others. But I mean, follow us on LinkedIn. We always shout about what events we'll be at.
Thank you so much, Ashley. I've learned so much about batteries, and this podcast is really about making this kind of encounters and making sure that we get to learn from people with a very different perspective. So thank you very much for this very, very candid conversation. I loved it. So thank you, and best of luck for the next steps, and enjoy your break. You deserve it.
Yeah, thank you. It's been really great chatting with you. Thank you.